Welcome everybody to another one of SafMed's presentations. Hope everybody is doing well under our current conditions. I know everybody's having a few issues with load shedding, etc. But let's spend some time focusing on something different. So this is webinar 3. And it's brought to you by SafMed. Thank you, SafMed, kindly for sponsoring these webinar series. SafMed not only is your solutions partner for the last 30 years, both in the theatre environment and the CSSD, but we also pride ourselves in giving back and in education. For those of you who have watched the series or have been involved from the beginning, this is webinar 3 of our 2021 Sterile Barrier Systems webinar series. The sessions live are being hosted on a Thursday morning, and next week, the 4th of November, will be our last session on this particular topic. If you've missed any of the webinars or any of the previous webinars, please feel free to email us and we'll send you the links to the recordings. Those of you that have been attending from the beginning will remember that in webinar 1, we started off by discussing what is a sterile barrier system, what different types of sterile barrier systems are there, how do we know which one to use. In webinar 2, we looked at some really interesting information about how sterile barrier systems are made, how the web is formed, what the machine looks like. We looked at the fact that they must comply with specific standards, the manufacturing thereof, and that compliance standard is 11607. We took an in-depth look at the various test methods that are used to make sure that the products do actually comply with the standard. And we delved into the difficult question of, is standard cotton linen a good sterile barrier system or not? Today, webinar 3 and in webinar 4, we'll talk about this particular standard called ISO 16775, which is the application of 11607 and works on the clinical setting. So these are the things we'll talk about today. We'll remind ourselves of the definition of a sterile barrier system and its protective packaging. Then I want to delve into that question of how many layers do we actually need? Then we'll look at the outline of 16775, and we'll learn more about things like a validation plan, operational qualification, and performance qualifications. And today we're focusing specifically on reels. As you can recall, we learned in 11607 that a sterile barrier system is the minimum package that prevents the ingress of microorganisms and allows aseptic presentation of the product at the point of use. The protective packaging is the configuration of materials designed to prevent damage to the sterile barrier system and its contents from the time of their assembly until the point of use. And the packaging system is a combination of both the sterile barrier system and the protective packaging. And in most instances and in most scenarios, especially when it comes to sets, generally speaking, we're referring to wrapping with 2 layers of wrapping material, a protective packaging and a sterile barrier system combined. And under the correct circumstances, that should be all you need to manage your sets, specifically I'm referring to now. And but of course, we don't always have ideal circumstances in our lives, and we may find ourselves with very difficult to manage sets or trays, things that are heavy, things that have got protrusions or little foot pieces that stick out, or supports, or perhaps we've got some really older trays and containers with very sharp edges, or we've got wire baskets, and those wires sometimes come loose over time where the welding has deteriorated, again with a foot protrusion at the bottom of the tray. Or we've got this older type of tray systems. I don't see too many of those around anymore where the weld sometimes breaks down on the side, or any form of sharp edges. And of course, those sharp edges could also apply to bowl packs or receivers or all sorts of items that develop sharp edges over time with use and with deterioration. Under difficult circumstances like that, it's very difficult to expect the sterile barrier system to stand up to these rigorous circumstances. We can't expect paper material, and we certainly can't expect lower grammages of SMS to withstand these kinds of circumstances. It does make it difficult, and that is when we tend to start making use of things like standard cotton linen as a third external layer to try get some form of protection. But it is based on our circumstances. Although I'm sure many times we've asked ourselves, how many layers do we actually need? How many layers of sterile barrier system do I really need? If I'm packing a simple, lightweight, light handle, and I'm putting it into an Acceptor bag, perhaps, or a SteriReel, do I need 2 layers? Is 1 layer sufficient? It's a very good question. Does a stocking that's going to be sterilized for the theatre need 2 layers of sterile barrier system? Now, everything we've covered so far in the ISO standards is not going to tell us how many layers we need. That's not what the standards are designed for. So then we need to start thinking about what's in there in the published papers, what's there in what do the guidelines say, and what do I know from risk assessing my set of circumstances. So one of the interesting papers to look at is this from De Bruyn et al., published in 1999. And here's the title. Remember, this is from Central Sterilization, a German publication that's published in both English and German. So hence the English may be a little tricky, and De Bruyn et al., to the best of my knowledge, are Dutch. Single or multiple wrapping of medical devices, procedure assessment through research. So let's go through this paper and let's understand what De Bruyn et al. Understood of how many layers of wrapping or sterile barrier systems do we need when wrapping our medical devices. In that introduction, De Bruyn describes that sheets are normally applied in double layers. See-through pouches are sometimes used as single layers, and containers are often used without an inner wrap. And note that the Dutch seem to debate the concern about whether or not the tray within a container should also be wrapped, hence the 2 layers. Some countries debate that, other countries don't. And of course, they weren't referring to a piece of linen. De Bruyn does go on to say that, of course, the goal of a sterile barrier system is to keep the contents sterile. He also discusses the fact, I think it's a he that is, that the linen is no longer used, and this is in 1999, as I said, that modern single-use packaging material gives a level of barrier protection that has never been able to be achieved by hospital linen. Again, remember this was 1999, so I'm referring to standard cotton linen, not the modern-day laminates and linen designed for this purpose. He then raises the question, is double wrapping really necessary? In the introduction, he goes on to say that the Dutch standards, however, are very clear, and that a single layer of packaging is vulnerable, 2 layers is mandatory, and they should be applied independently. Again, a debate all over the world. Some people will like independently or simultaneous wrapping or a sequential wrapping. That detail will go on to in webinar 4 about sequential versus simultaneous wrapping. Different strokes, different folks, different societies, different views around the world. Continuing through his background information, he then lists the factors that affect the ingress of microorganisms into a package, and he relates it to 2 main aspects. One being damage to the packaging, and the other being insufficient barrier properties. So insufficient barrier properties is referring to the quality of the wrapping material and the packaging concept. So also around the thought of did you wrap it with enough layers or not? Were you able to get the sterilant inside of the actual, through the actual packaging? When we delve into the section of damage to the package, he lists how this could possibly happen. Of course, damage to packaging can occur before use, so in manufacture, on arrival, during transport, once you're preparing it, a number of ways that it can get damaged. During wrapping itself, and of course he refers to sharp edges. And during wrapping, I've seen a lot of people with very confined spaces. So they'll make their bed or their trolley or their feeding trolley that they work off, and they'll do a set, and then they'll do the next set, and then they'll pile the third set on that, on top of that, the fourth set on top of that, the fifth set on top of it, so that at the end of the day, you get 6-8 sets with a really huge amount of weight on them before it's even gone into the sterilizer. Then, of course, loading into the sterilizer, how we handle the package whilst we're loading it and how we load it in the sterilizer. During sterilization, and I refer specifically to this little extract, he says, during the sterilization process, packaging materials may become wet and may lose their original strength. Heavy trays may settle on the supports and push through the package, causing holes. That's why we would always suggest that an item being wrapped in a sterile barrier system, a sterilization wrap, has a flat base to the tray. Of course, the tray that's going to go inside of a container generally has some feet on it or some form of support, but when you're wrapping items that are going to be placed in a sterile barrier system of wrap, it really and truly needs to be a flat base. That makes good sense. When unloading the sterilizer, of course, the wrapping or the packaging is at risk, and he goes on to state that just like loading, unloading should also be done with great care. Wrappings are still moist, and many materials regain their full strength only if completely dried and cooled. And needless to say, handling during transportation. So those are all of the areas that he discusses in the background to the study on how many layers of sterile barrier system do we need. Now, the extract, whether or not damage occurs, also depends on the quality of the packing materials, the number of layers, and the quality of the loading and unloading aids, so the trolleys that we use to get the stuff out the autoclave or whatever device or the sterilizer it's going through. Also, he refers to the storage and transport facilities, and last but not least, the way in which the personnel handle the packages. We know that heavy sets tend to be dragged more. We pull them on the corners, we drag them on the surfaces because it's hard work to lift them. We know that if we don't place them at ergonomically correct heights, we don't manage them well. So the guidelines always say that heavier sets should be at around waist height or slightly lower perhaps, and the lighter trays can be packed higher to make it ergonomically easier. Ultimately, I'm going to hope that if I were to audit your CSSD, as I've done numerous times in numerous CSSDs, that I don't find sets looking like this on the shelves, because that is terribly disappointing. If CSSD have released a set that looks like that, these images were taken by myself on trolleys and trays, one in the storeroom and the other one actually at a setup outside the theatre about to be used. I digress back to De Bruyn's published paper. He then uses a series of very complex calculations that I struggled a little to understand, but what he was calculating or looking at was measuring the heat of a tray or a set as it came out, the fact that there was some cooling. Because there was cooling, there was movement of air naturally from the outside onto the inside of the tray. Of course, that then puts the items at risk for contamination, and that's where we want the sterile barrier system to keep the microorganisms out. At the end of the day, he refers to bacterial efficacies of various materials. And in this context, he spoke about some textiles, he spoke about crepe paper, and he spoke about non-wovens. So a number of years ago, I was aware of a system that the Dutch were using at the time, and it was like a guide for how long something would stay sterile for. And I'm just using some suggested explanations or examples. So, for example, a light handle or an item packed in one layer of a septic bag, maybe that's okay for 24 hours, something packed in 2 layers of an aseptic bag, because remember that's paper-based, maybe that's a week, something packed in 2 layers of non-woven, maybe that gets 3 months or 6 months, so it was a guide that they had created for themselves. Remember, of course, that sterile storage is event-related, and that's really what we focus on now, and those events include how the items were handled, where they were stored, and the number of layers that were used, and then, of course, bearing in mind the type of sterile barrier system that we used. We learned last week, remember in the testing methods, that they will have different efficacies. Different materials will have different efficacies, and we know that from our testing. Anyway, back to De Bruyn. In essence, his conclusions were as follows. Using single-layer packaging means both less work and less material, and helps to reduce the cost of packaging medical devices. But on the other hand, a single layer of wrapping material can be damaged easily. It has limited microbial barrier properties, and the aseptic presentation may be problematic. And ultimately, the decision between single and double wrapping needs to be both a technical decision, your local regulations, and your hospital standard operating procedures. And one needs to take into account what happens in the operating room. And that's the considerations you need to do. Then you need to do a risk assessment around that to make decisions on how it is you're going to package your devices. What do the World Health Organization's 2016 guidelines say? Clearly, medical device regulations include a requirement that sterile devices should be designed, manufactured, and packed in non-reusable packs and/or according to appropriate procedures to ensure they are sterile. A clearly stated preference for single-use packaging as the primary packaging for sterile devices is now observed, and double wrapping is recommended for medical devices used in the operating theatre. Okay, ISO 16775. So ISO 16775, as you can clearly read over there, is guidance on the application of 11607 Part 1 and Part 2. As you can see, Part 1, the scope, introduction, and Part 3 is guidelines for healthcare facilities. Part 4 is guidance for industry, so guidance for the people that are making your suture material and your gloves and your syringes and that packaging. So we obviously are going to focus on the guidance for healthcare facilities on Part 1 and Part 2. Part 2 being about forming and sealing, how we seal our packs, how we form them, how we seal them. In the first section, it talks about the fact that before you purchase any form of sterile barrier system, you need to evaluate it thoroughly. Of course, you need to have made sure it's made of traceable materials, it's non-toxic. We learned all about that last week. You need to have the evidence of the testing. We learned about that testing last week. And of course, your supplier can provide that to you. And then it speaks about the fact that there are various selection considerations. And those include the duration and conditions of storage, the size, the weight, and the shape of the item being sterilized and packed, the means and the conditions of transport. So all of these factors have to be taken into account when you're trying to decide on what sterile barrier systems to order, to buy, to use, to pack with. The standard also talks about assembly considerations, and you need to bear that in mind, how the items to be oriented within the packaging. Do you need to shield something because there are sharp objects? And that shielding material has to allow for sterilization, and that shielding material must not undergo any physical or chemical changes. So if you take that into consideration, you may ask yourself, is it a good idea to make use of tip protectors made of Jacques catheters or feeding tubes or silicone tubing that we create or use? Is it a good idea to clamp our sharps like skin hooks in elastic bands? Is that really a medical device? Things to think about. Weight of the packaging system and its contents should not exceed manual handling regulations, and the current national regulations range from 5 to 11.4 kilograms. That's just handling aspects. That's not around the other guidelines of managing that huge mass of metal in your load. Just handling. I remember going to America once and thought we were clever. My hubby and I, we packed all of our stuff into one big suitcase. It weighed over 10 kilograms, and it was a huge issue the whole way through America because of the handling and the weight issues. In the guidelines, there's also reference to label considerations. So if you've got a fancy track and tracing system, it may produce a label that needs to be attached, or you might be writing with a ball pen, writing with a marking pen, whatever it is you're writing with. And of course, you need to consider about where to write and what to write with. Now moving on to section 3.2.2.6 of ISO 16775, it says common choices for sterile barrier systems. And in general, sterile barrier systems can be manufactured using mainly but not limited to the following concepts in the hospital setting: a sealable pouch or reel and or sterilization wrap and or reusable containers. And what aspects do we need to think about when we are using these systems? So now from here on out, I'm really going to refer mostly to sterilization reels, focusing on that. In webinar 4, I'm going to compare, well, not compare because they're two different entities. I'm going to refer to all these considerations that you should be bearing in mind when you're using sterilization wrap and when you're using sterilization containers. Okay, sealable pouches and reels are preformed sterile barrier systems. As you know, they're available in two different forms, one being a continuous reel or roll type that's sealed on two edges. The roll is unwound, cut to the desired length. The medical device is placed between the two layers and both ends are sealed. The pouch version, of course, is pre-cut, and that is sealed on three sides. And depending on your institution, you may use either or both. We tend to find that most hospital settings use the reel form so that we can cut them to the sizes we need. And some smaller institutions that don't have heat sealers will use pouches. Here are some aspects that need to be considered as per section 3.2. The size and strength of the packaging material must be based on the medical device to be packaged. Makes logical sense. If you've got a tray of eye instruments that are very light, you may have chosen to wrap them in just a SteriReel, or perhaps not. If you've got a heavy neuro set, obviously you're going to think twice about a SteriReel. You'll be focusing on using sterilization wrap or a container. When you're using SteriReel, of course, anything that is too large or any sharp edges will create extra pressure on the seal. And extra pressure on the seal can cause it to rupture. If you think about the steam sterilization process, remember we've got to take out the air, we've got to put in the steam. I'm thinking of an autoclave at the moment. The packaging material goes through a tremendous amount of stress during that time. Remember, we are we're creating a huge vacuum in there. It's really a pull and a tug and a pull and a tug on the materials. So if you have got anything that creates extra pressure on the seal, you could end up with a rupture on your seals. You also need to make sure that there's enough space for closure. That makes logical sense. You want to make sure that there aren't too many small items within a package that'll move around within the sterile barrier system and then damage it. You do not want to fill the sterile barrier system to, it says, don't fill it beyond 75% of the inner surface. I guess that makes good sense. You don't want to overfill it. And if you look at the item on the left, to me that looks a little bit too tight. Another important aspect, of course, is if the product is of great height, you can always think of a gusset reel, but you also need to give an increase of distance from the seal so that you'll be able to seal the packaging. Often you learn that the hard way when you cut the packaging too short. Right, 3.2 goes on to say that when two pouches are used, the inner pouch should be able to move within the outer pouch because this allows for penetration and it prevents the pouches sticking together. Avoid folding the inner pouch to fit inside the outer pouch. Obviously, that's all about ingress of steam as well, because if the steam needs to get through 4 layers, it makes it a hell of a lot harder, as well as the fact that you want to prevent stress. Folding the inner pouch will create additional stress on the seams and the seals. Always, of course, remember to pack paper to paper and plastic to plastic. All seals we know should be smooth, no folds, no bubbles, no wrinkles. Right, let's talk about the heat sealing device. The sealing devices need to be able to control and monitor the critical process parameters of sealing. And those process parameters include temperature, pressure, and sealing time, sometimes also referred to as dwell time. So if you still have the old-fashioned foot-operated heat sealing device, please, the standards have changed. We need to move on. You need a heat sealing device as per the standard that has alarm warnings if there are any deviations from the process parameters of temperature, pressure, and sealing time. You need one that can control it, and you need one that can monitor it. A foot-operated heat sealer doesn't do that. Operators should not modify the critical process parameters unless they have been trained to do so. Of course, it's a bit tricky if you are a heat sealing normal SteriReel type device that is going into an autoclave and you're doing a Tyvek type item. Most likely the best thing is to have 2 separate heat sealers, because otherwise you will find you will need to adjust the temperatures the whole time, and that will be both problematic and time consuming, and plus you have to fiddle with the controls, and that has its own risks. The sealer you buy must be able to attain the parameters stated by the Sterile Barrier Systems instructions for use. So obviously it must be able to attain those temperatures, for example, or that dwell time. Use a sealing device that is designed for sterile barrier systems, not one designed for arts and crafts or food parcels. Please, we need the correct type of heat sealing device. Closing accessories. Closing accessories that compress packaging should not be used, like elastic bands, paper clips, staples, or string. The item on the right with the it's a nylon cord, really, rope type material, is not something I've seen very often. I've seen it once or twice in a provincial setting, and it was applied before sterilization, and it was used mostly to facilitate carrying of the sterile barrier packaging, and the idea was to make it easier to carry. But of course, that rope system is going to cut through the sterile barrier system and really and truly is not ideal. When we're loading the pouch must be loaded with the grip of the medical device towards the opening end so that the device will be presented aseptically. Now, everybody in theatre knows that, and most people in CCD know that, but sometimes we forget to teach everybody who's doing this job. The seal area is considered non-sterile once opened, or when opened. Right. The pouch should be opened according to the manufacturer's instructions for use. We need to leave a space above the seal that is intended to be the opening side. So of course, if we're making that the opening side, that is the side that the grips of the device or the handles of the device must face for aseptic presentation. But another important component is the peel direction. And I'm not sure if you've seen the peel direction before, but on all of your sterile, or most of the sterile barrier systems that are available in South Africa, to the best of my knowledge, have got a peel direction arrow on them. So if you look at the image on the right, that'll open in the right direction, which is awesome. If you look at the image on the left, it's opening the wrong way. If you don't open using the correct peel direction, you will end up with additional material. So what happens is that the fibers delaminate and you end up with those fibers on your devices. And that's why there is a peel direction, so that you know which way to do it. You don't want to contaminate your devices with these fibers. Additional aspects to consider when it comes to labeling. The ink needs to be non-toxic. The newer heat sealers, of course, come with systems that you can type in some words and it can label the item for you, which is quite handy. We should not write on the plastic side, sorry, we should not write on the paper side. If we really have to write, then we need to write on the plastic side. We don't want to write within the sterile area. And of course, importantly, we do not want to write with a ballpoint pen because that can damage the packaging. So try writing on the plastic side outside of the sterilization area. We also don't know, I mean, most of us use ink pens from wherever, and we don't know what they contain, and we don't want that material inside and on our instruments and ultimately then in our patients' abdomens. I went through, I can't remember how many pictures I looked at when I was trying to look for examples of doing it right. And I didn't find one picture of a device packed perfectly, correctly in a sterile barrier system. I found many pictures of things that weren't correct, but I never found a picture of an ideal packed device. I didn't have one as an example to show you. Right, so moving on a little bit more to talk more about the validation requirements for forming and sealing. So these are quite complex. We've spoken about all of the general aspects from section 3.2. And of course, we will also, as I said, focus on containers and wrap, their general aspects next week. But let's talk now about forming and sealing. So we're talking about forming and sealing and validating the process as a whole and bringing it down specifically to SteriReels as well. But these concepts you need to bear in mind when you are doing the same thing for wrapping and the same thing for containers. Okay. So here in 3.2, it talks about the validation process, and the validation process has 3 steps to it. The first step, and they interrelate, as you'll see as the images come up. The first step really is a validation plan. Step 2 is operational qualification, and step 3 is performance qualification. In the validation plan, the document begins by listing the responsibilities. Who's responsible for what? The next thing you need to do are SOPs, standard operating procedures, for every type of device that you actually wrap. So whether you've got items in aseptic bags, whether you've got an item in an aseptic bag and a layer of sterile wrapping material, whether you've got stuff in an autoclave, whether it's going, if you've got something in an SMS that's being sterilized in an autoclave and something in an SMS that's being sterilized in vaporized hydrogen peroxide, for example, you need separate validation plans for those. So every type of item, every type of packaging configuration, and every type of sterilant that it goes through, you need a validation plan for each one of those. And you need a standard operating procedure for all of those. You also need to evaluate stuff once they've gone through the sterilization process. You need to define acceptance criteria, evaluate packs, and you end up with a validation approval. So we're going to look at part 2 in a little bit more detail in a second, but just to reiterate, operational qualification is assembling a whole series of packs and evaluating the packs. The validation plan is the whole process. And step 3 is the performance qualification, where you're actually now testing the packs after sterilization. So part 1 is how did you assemble it? Is it working? Part 2. Part 3 is assembling it, sterilizing it, and then evaluating it after sterilization. Right, part 2. Okay, so you're writing SOPs for every one of the processes. Once you've written the SOPs, you have to train the operators, firstly, to do as they are meant to be doing, as in the grip of the handles facing that way, it peels this way, you leave a gap over here, you only fill 75% of it, you close it properly with the heat sealer, that's working properly at the correct temperature. Then you assess the operator for competency. You prepare sample packs, which have to include worst case configurations, so really heavy items or awkward things, so bulky things that are difficult to seal. Then you need to assemble these packs and evaluate them, look for them for proper closure and integrity. Do they look good? Have they come together properly? Excellent. Open some of them now and actually assess how they open. This is before sterilization, remember? Did it work? Didn't it work? Part 3 of the process, start all over again. You assemble 3 sets of 10 samples of sterile barrier systems, taking into account different variations, different operators, different time of the day, different types of materials, and bearing in mind worst case conditions. And then you need to sterilize them. So you're assembling 3 batches of 10 items in each batch. And you also want to make sure that this processing happens, including worst case scenarios, different autoclaves cycles, different operators, different times of the day. You then sterilize the items prior to evaluation, and you need to document the batches. Now, this is all part of your validation process, validating that you are doing it properly. In the documentation, it includes stuff like who's the operator, what's the time, what's the date, what method, what closure did you use, what were the contents of the sterile barrier system, and then you actually evaluate these 10 samples to see how it turned out. So at the end of the day, there are a whole bunch of annexes and checklists in ISO 16775, but of course these documents are licensed or produced under license, so I can't share them all. But ultimately what I'd like to do is I went through, of course, in 2010 in one of our SteriReview issues, Pat Ailing, who sat on a number of our SANS committees and is still a chairperson of many of our SANS standards, wrote a very nice article describing this process for us. In fact, that's what I've used here. To help us understand the process. And I think what we'll do now is there's definitely a lack for us. So SafMed decided the best thing we should do is now actually write a guidance document on how to do this validation process and make some tables, make some checklists to make it easier for us in the future. Because we are supposed to be doing this if we change barrier materials. If we've never done it before, obviously we need to do it. But if you're changing your barrier system supplier, if you've got a new heat sealer, if things have changed in your processes, you should be doing this process and reevaluating or revalidating each time. So the checklists look something like this. You can see it starts with name of the facility. That falls under the section of responsibilities I spoke about. Is this the first time you're doing it? Is this revalidation? Then description of the assembled sterile barrier system, what's in the contents, have you looked at worst case scenario, what is the worst case scenario, how many things did you actually assemble, have you got SOPs, then when you describe the sterilization process it went through, it's quite, as you can see, it's quite in depth. The sterilizer, its make, its model, its serial number, the type of sterilant, is it steam, is it plasma, is it... plasma, they have to change that. Is it vaporized hydrogen peroxide? Is it the worst case scenario? What else are on the checklists? Here we go. Descriptions, who supplies it? Is the supplier the manufacturer of it? The name of the company? All those details around the actual product itself. Then description of the sealing device. What's the make and model? What's the serial number? Who supplied your heat sealing device? Very detailed information. Has the supplier given you the sealing temperature? What is that sealing temperature? Quite in depth. When last was your heat sealer serviced or calibrated? In depth process, as you can see. So that's why I think it's time that we write a really nice guidance document so that we should be doing this. Nobody's done this to the best of my knowledge yet in the country, and it's something we really and truly should be doing. This paper was published in 2014, by the way, the standard, of course. The other thing that matters is that, by the way, is this publication is busy being reviewed at the moment. I've had the fortunate pleasure of being able to look at the newer document, and the newer document even talks about the conditions of the environment in which we create the packages. You know that in many of the industries that some of the stuff's done in the clean room, and we don't treat our CCT like a clean room. And that little tippet I gave you right in the beginning where it says you may not eat or drink, that comes from the new one. I'm not allowed to share that yet because it's not finalized, and we're hoping for that to be published in 2022. And that'll be great because it'll give you some more reference material on how we should be handling the clean room or our area where we do the packaging, and we certainly should not be eating and drinking and doing all sorts of odd things in there. It's a clean room in essence. So then we have to define our acceptance criteria. So what are we happy with? What will we sign off and say this is working correctly? Here are some examples, as you can see, that you're looking for when you're inspecting it. What's the seal integrity like? Is it wide enough? Are there any wrinkles or channels? Are there tears or punctures in the packaging? Was the sterilant able to penetrate the packaging? Was it dry at the end of the cycle? Were you able to open the reel without contaminating the contents? And obviously then things like the peel direction, the space, did you put it in the right direction? Those kind of aspects. So that's what you have to define. You define what are your acceptance criteria. So reminding you the validation plan, the operational qualification, and the performance qualification. Responsibilities, standard operating procedures, training people how to do it, assembling the test packs, evaluating them, then doing it again, but then sterilizing them, and then when they come out the sterilizer, evaluating the test packs to decide whether or not they have been approved. Are you approving this process? Are we doing everything 100% correct? So what did we cover today? Sterile barrier systems and its protective packagings. How many layers do I need? Do a risk assessment. ISO 16775, what has it taught me? A validation plan, and it's taught me how to do an operational qualification and a performance qualification specifically around items packed in sterilization reels. Next week, we'll look at the same detail, but focusing on wrapping, sterilization wrap, and containers. What should I be looking for? What should I be testing? Thank you very much for joining us again today. As normal, we will email you the link to the test questions. If you'd like a certificate of attendance, you will need to complete that test. And hopefully we'll see you again next week. I have already sent out the meeting invite for next week, so don't forget about it. Have an awesome day. Thank you very much.